Here we have a question number 1. A rocket is stationary on the launch pad at time t is equal to 0. The rocket engines are switched on and exhaust gases are ejected from the nozzles of the engines. The rocket accelerates upwards. Figure 1.1 shows how the acceleration of the rocket varies between t is equal to 0 and time t is equal to tf. So here in this figure 1.1, we have shown a graph between acceleration and time. A little information. This line shows the increasing acceleration, and this straight line shows the constant acceleration. Actually, we are going to need this information in part B of the question number 1. So here we have first question, define acceleration. As I told you, this is increasing acceleration and this is constant acceleration. So define acceleration, it will be rate of change of velocity, you can say, or change in velocity per unit time. So that would be the answer of question number 1, part A. Rate of change of velocity is known as acceleration or change in velocity per unit time. So move to the next part. Here we have part B. On figure 1.2, sketch a graph to show how the speed of the rocket varies between time t is equal to 0 and time t is equal to tf. So we have to sketch the graph. They already have given us the axis, speed axis and time axis, and we have to sketch a graph over here. So as in the previous question, I told you that there are two lines in which one line represents the increasing graph and the second line represents the constant graph. So you have to draw graph. It will start from origin O, and this line shows the increasing acceleration. Then we have like this straight line. This straight line shows the constant acceleration. Speed time graph has a gradient. Speed time graph has a gradient. This gradient is equal to acceleration. Gradient is also known as slope of the graph. So this shows increasing gradient. This line shows increasing gradient. Acceleration is increasing here. When the rocket is launched, it gains speed and it accelerates. So after that, its acceleration becomes constant. So this steep straight line shows the constant gradient. So you have to draw the speed time graph for rocket motion. The rocket starts its motion when the time is 0. So it will start from the origin O, and it starts right from here. It will be the curved line. This curved line shows the increasing gradient or increasing acceleration. Then this line becomes straight line, and this will represents the constant gradient. I hope it will be clear to you. So let's move to the next question, part C. Sometime later, the rocket is far from the Earth. The effect of the Earth's gravity on the motion of the rocket is insignificant. As the rocket accelerates, its momentum increases. Number 1, state the principle of conservation of momentum. I hope you know the answer. Of course, you have learned about momentum. So, momentum is also known as the quantity of motion possessed by the body due to its mass and velocity. So, a conservation of momentum. Initial momentum is equal to the final momentum. This question has 2 marks, so we have to write at least 2 points to justify our answer. Initial total momentum is equal to the final total momentum, and this happens for the isolated system in which no resultant external forces are acting. So this will complete your answer. Come to the second part, explain how the principle of conservation of momentum applies to the accelerating rocket and the exhaust gases. Okay, for this answer, you have to explain how law of conservation of momentum can be applied to the gases and the rocket motion. For this purpose, you must know how rocket works. For this, I will show you this slide. Before launching the rocket and the gases are at rest, so their initial total momentum is equal to 0. And after launching the rocket moves in the upper direction and accelerates, and it has some momentum, and gases are exhausted, and they also attain some momentum in the backward or downward direction. So momentum of rocket and momentum of gases are equal but opposite. So after launching the rocket, momentum of the system must equal to 0. This is how you can apply the law of conservation of momentum on rocket and gases. So I repeat it, before launching the rocket, momentum of the system is 0, initial momentum of the system is 0, and after the launching the rocket, momentum of the system is also equal to 0. So now you can write your answer over here. You can write the exhaust gases. The exhaust gases experience an impulse and gain momentum in the downward direction. Gain momentum downwards to keep total momentum conserve or constant, or you can say that 0, because before launching the rocket, momentum was 0. To keep total momentum 0, the rocket experience an equal but opposite impulse and gain momentum upwards. Rocket experience an equal but opposite impulse and gain momentum in upwards. This is how you can write your answer, because this the answer of this question consists of 2 marks. So you have to explain how the principle of conservation of momentum is applicable to rocket and gases.